So we're going to solve a linear system of equations by graphing. So we're going to have to graph two lines. So a system means there's more than one. We're going to have to graph both of them in order to figure out the solution. So there are different ways you could do this. For this problem, I'm going to use slope-intercept form. And then for the next one, we're going to find intercepts and do it that way. So because you have two variables, you technically get two variable answers. You're going to have an x and a y. So let's take our first equation. 2x minus y equals 9. I'm going to add the y to the right side, which is going to get rid of it on the left. So 2x equals 9 plus y. I'm now going to subtract the 9 to the left side. So I'm going to have y equals 2x minus 9. My y-intercept is negative 9. And my slope is 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. So if your teacher has taught you this, this is the rise over run method. You start at the y-intercept, use the slope, and then we connect the lines, or the dots. So there's our line. I'm using different colors, so it's easier for me to see where they are. But if you're not, you should label this so you know where you are and what you're doing. So the second equation, 6x minus 3y equals 9, we're also going to write this in slope-intercept form. I notice all of these are divisible by 3. So what I'm going to do is I'm actually going to divide everything by 3 first. You don't have to do this. You should get the same answer with me if you just move things around and solve for y. But I'm going to try to make this easier. 2x minus y equals 3. This is eerily similar to that first problem. So I'm going to add the y to the right side, which is going to get rid of it on the left. I'm going to subtract the 3 to the left side, and I'm going to get 2x minus 3. So negative 3, and my slope is the same. I mean, I don't even have to graph this because I just did another video on the solutions, but we have two parallel lines. So if these are parallel lines, this is not going to have a solution. They're never going to intersect. And the reason is they're parallel. But when we graph this, you'll see it. And there's our graph, y equals 2x minus 3. So we graph this, there's no solution. They don't intersect because they're parallel. So but that's how you do it in slope-intercept form. You could solve them for y and graph each one. The second problem, we're not going to do this method. We're going to do something a little different. So here we're going to find the intercepts, and we're going to graph using the intercepts. And the reason we're going to do this is based on what I'm seeing. So the way you find the intercepts is you're essentially using 0 for one variable to solve for the other variable. And these numbers work out very nicely. So for x plus y equals 6. For my x-intercept, I'm going to make my y value 0, and I plug in 0 for y. X plus 0 equals 6, so x is 6. For my y-intercept, I'm making 0 my x, and I'm going to solve for y. So 0 is x, 0 plus y equals 6, y is 6. So I can graph this because I have 2 points. X is 6 comma 0, y is 6 comma 0, and all I have to do is connect these points and I'll have my graph. So there's my graph. X plus y equals 6. And then now I'll do the second one. So x minus 4y equals 16. So same thing, I'm going to find the x-intercept. So I'm going to look for x when y is 0. So if y is 0, I get x minus 4 times 0 equals 16. Well, 4 times 0 is 0. So our x value is going to be 16. For our y, x is 0, and now I'm going to solve for my y. So if x is 0, I get negative 4y equals 16. I'm going to divide by negative 4, and my y value is negative 4. So here's where the problem is. Y is negative 4. X is going to be all the way down here when x is 16. So in this specific case, it's not going to work, right? But sometimes you get numbers like you did for the first one that's going to be easier. So all we have to do, if you wanted to, is change this into slope-intercept. So I'll do both of them. For the first equation, your slope-intercept be y equals negative x plus 6. So if you do all the work from that you already know from before, then that's what you should get. And for this other one, you would get y equals 1/4 x minus 4. And if you use that slope, you start at negative 4 and you go up 1 over 4. Up 1 over 4. Up 1 over 4, that would be at 12, and then that would be at 16. So we can graph this, and then we'll see where they intersect. So now we have this graph. You could label it either way, but now it's very clear that there is a solution because there is an intersection. It does exist. So the solution, because we are being asked to solve this, is going to be 8, negative 2. So if you need to write down specifically when x is 8 and when y is negative 2, that's where both of these equations intersect. So when you're graphing, be strategic. You can use multiple methods. Some methods are going to be easier than others. But once you graph them, you should be able to see your solution very nicely.